Okay, so this is activity number 16 from the Raspberry Pi Pico book. And what we're doing here is we're sensing temperature with a temperature sensor through I2C and the Raspberry Pi Pico. So here we got our board, and right here we have our program running, and we can see it's running live. It's updating, and what's going on is so we got our actual temperature sensor. It's embedded in a small board, and so here we got all the terminals, and there's just a little explanation on the pointer register, and right here. So here they're using a TMP 102. So I couldn't find that model. But we're using actually a different temperature sensor, but it's still an I2C temperature sensor, so it still works. And so here we got our block diagram with the connections and the actual code itself. So we can see we're technically at 26. Somewhere around 26 degrees, and if I actually heat up that's my bad. Okay, I made a shortcut with my finger. But it's running again. Okay, so explain the code. First, we import our libraries. We need to use the I2C one. Then we initialize the I2C bus, and so right here we initialize the I2C bus, which this creates an I2C bus setting the frequency and the SDA and SCL pins, in this case assigned to pins number 9 and 10, GPIO 8 and 9. After that, we set the device address and the pointer register, and then we actually read. So we set we initialize a 2-element bracket here. Where we'll read the temperature. After that, we define the least significant bit resolution of the temperature sensor right here, and then we assemble here the 12-bit temperature raw value. Then right here, so we check if the 12-bit value has a signed bit, and right here we compute the two complement negative magnitude. This complements the two negatives and adds 1 to the inverted value. And after that, we convert the magnitude to a negative temperature degree right here, multiplying it by the LSV, then negating right here. So otherwise, we just multiply it, and we return the actual value. And on our while loop, forever loop, we just read the temperature and keep on reading it every second, and we display temperature on the serial monitor, which is what we're getting right here.